We're going to cover three very common statistics in this lesson. The first one is our measure of centralities, which is mean, median, and your trim mean. Second one is going to be quartiles, or quantiles. And the third one, standard deviation and variance. The three different measures of centrality, mean, median, and the trim mean. All three are used in different scenarios, so you might want to use the mean, all the values added up and divided by the number of values. The pro to the mean is it's natural and it's easy to compute and has pretty nice mathematical properties. The con is it's really sensitive to extreme values, outliers. The median, you have to sort the values and take the middle one, or if there are two middle ones because you have an even data set, you take the two middle ones and divide by 2. You take the mean of those two middle ones. The good part is it's resistant to extreme values and pretty easy to describe to someone. The con is it's not as mathematically tractable and it's not always easy to sort the data to calculate. Finally, the trimmed mean. Like the mean, but you cut off some of the tail end, the smallest and largest values in the data set. It's kind of happy medium between the mean and the median. It's resistant, the pro is it's resistant to extreme values, and it shares nice statistical properties with the same as the mean. The cons, you need to sort the data. For this lesson, we'll use the iris data set. This is a data set that is already in R. Specifically, we're going to use the sepal length column. Here's what the data set looks like, or just the first 5 observations. You see we have a bunch of different columns. But again, we're just going to use the sepal length. So if I show you sepal length, it's just going to be a vector of a bunch of different numbers. First, we need to find the mean of the sepal length. We do this by dividing the summation of the vector of the sepal length by the number of values in the vector. We need the number of observations. I'm going to call that n here in the sepal length column. So it gives us 150 observations, and I sum them up and I divide by n. So it gives me that gives me a mean sepal length of about 5.843. For the median, we need to find the midpoint. I find this by dividing the number of observations by 2. Just right here, I'm going to call it midpoint. And 75, which makes sense because I have 150 values. To get the correct value of the median, I have to order the values in sepal length. I do this with the sort command. Sort. It's a pretty easy command. It just sorts from lowest to highest. And that, you take a look at that. I just saved it as a temp value, and I just call on the midpoint value that will give me the median. Notice the median is 5.8, which is pretty close, but not quite the same as the mean. Finding the trim mean is a little trickier, so I will use the built-in commands in R to find the trim mean. In fact, R has commands to find all of the previous actions. We get the mean, the median, and this is the trimmed mean right there. Okay. Quantiles are kind of a measure of spread of your data. You have used quantiles before, but probably not realized it. For example, if you scored in the top 25% of a course on a test, you were in the 75th quantile. We calculate quantiles by ordering the data and counting to the quantile of interest. For our purposes, we are going to find the 25th and the 75th quantiles, also known as the first and third quartiles. Don't confuse quantiles and quartiles. I can use my previous sorted vector for this operation. I called this temp, so it's right there. First, I need to know where the 25th and 75th observations, 70th percentile observations are. So I'm going to run this, and they're at 37.5. I'll just round that down to 37. And 112.5, which rounds it when I call on it anyway. I call on those to get my quantiles, so 51 and 64. As before, R has quick ways to find those. Say 25th, 75th. Final topic is measure of spread. We have two common measures of spread, variance and standard deviation. They're directly related to each other, as the standard deviation is just the square root of the variance. The equation for the variance is in the notes, but basically the variance is the summation of each of the values minus the mean of the entire vector of numbers, and you square that. We also multiply this by 1 over 1 minus n because of mathy reasons, so it gives us an unbiased number. First, let's look at a long way to calculate this. I need the number of observations, which I already had, but I'll do it again. I need the mean of the sepal length, and then I can throw it in this math equation right here, which you can see as an easier number if you just go to Google or you look at the lessons. And that gives me my variance. Now, if I take the square root of that, I get the standard deviation. Standard deviation is usually smaller. For this example, it's bigger because I'm taking the square root of a decimal point. R also has quick ways to find both of these values. Why do we use the standard deviation as opposed to the variance? We often use the standard deviation because the variance can get really large and it can look really, really odd when we're looking at a huge variance because we're squaring each of those values.